Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at applications of quadratics. Basically, we're solving worded problems using what we know about quadratics and parabolas. So we're going to start with an easier question, then do a harder question. So the area of a rectangle is 270 centimeters squared. Calculate its perimeter if its length is 3 centimeters more than its width. So when we're doing worded questions, we're always going to start off by letting x equal one of the things we want to find. So what I'm going to do is I'm going to let x equal the width. Now, we need, in order to find its perimeter, the length and the width. So I need to define a variable for length. But I'm not going to use a different pronumeral other than x. We don't know how to solve quadratics with more than one pronumeral. In fact, there'd be infinitely many solutions. So if x is the width, I need to write the length in terms of x using an x. So if the width is x, the length must be x plus 3. It is whatever the width is plus 3. So the area of this will be length times width. But hang on a minute, the question told us that the area was 270. So now we have a quadratic equation to solve that we've solved heaps of times. So of course x times x and x times 3x. Now whenever you're solving a quadratic equation, you must make one side equal to 0. So x squared plus 3x minus 270. Now when you have large numbers like this as one of the coefficients in a quadratic equation, you're probably best off using the quadratic formula. So let's first calculate the discriminant of the quadratic formula. So it's going to be b squared minus 4 by a by c, which turns out to be 1089. So this quadratic here will have two solutions. One of the solutions will be x equals minus b plus the square root of the discriminant over 2a. And the other one will be minus 3 minus the square root of the discriminant over 2 times a. So if you put each of them in your calculator, this one here gives you 15, that's the 3 plus, but this one here gives you negative 18. Now we can't have negative 18 as a solution. You can't have a length of negative 18. So we conclude that this is the solution. So the width must be 15 centimeters, the length is 15 plus 3, 18 centimeters. So of course the perimeter is 2 times 15 plus 2 times 18, which is 66 centimeters. All right, let's now look at a harder quadratics question. So a shop notices that at $12 they sell 100 pizzas each week. For each $1 increase, they sell 5 fewer. We're going to calculate the maximum possible revenue. So straight away, when doing questions like this, quadratics or parabola questions that involve maximum or minimum, straight away think of this formula. The maximum or minimum value of a quadratic occurs at x equals minus b over 2a. So remember, for each quadratic function, for each parabola, it has a maximum or a minimum, but never both. So our goal here is to somehow come up with a quadratic equation and then use this formula here to find out the maximum. So note that revenue equals price by quantity. We're going to need to find an expression for price and an expression for quantity. So really what we're interested in is how many of these $1 increases they should make. So I'm going to let x be that. So let's now write the price and quantity in terms of x. So the revenue, which I'll call R, is price. So the price is going to be $12 plus however many of these price increases they put on the pizza. So that's the price. Now the quantity sold is 100, but for each one of the price increases, which is x, they sell 5 fewer. So the number they sell is 100 minus 5 times the number of price increases. So if we expand this, lo and behold, we'll get a quadratic. So we're just using FOIL to expand. 12 times 100, x times 100, then 12 times minus 5x, and then x times negative 5x. So we can just simplify by collecting the like terms here. Now what we want to do is find the maximum possible value of this revenue function. And for a quadratic, its maximum or minimum always occurs at minus b over 2 times a. So that actually gives us 4. That means the maximum revenue is attained when there are 4 of these $1 increases. So that means that the maximum revenue will be when they sell the pizzas for $16, they will sell 80 of them. And 16 times 80 is $12.80. That is the maximum possible revenue they will make. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.